Welcome to the final video of this week, week 5 for fun. Nope, that doesn't work. Never mind. Here we are. We're going to finish by talking about approximate change. So remember that thing that everyone asked about and everyone loved. The derivative can be written as a limit of the secant lines, right? And so we had something very similar, f of a plus h minus f of a all over h. And the exact derivative, sorry, this should be an approximately equal sign. The exact derivative is this limit as h goes to 0. But for small h's, these things are very close to each other. So we can approximate change with this. If we multiply both sides of this equation by this h, it cancels out on the right. And we're going to get that the derivative times the step size, or the difference, or the distance between the two inputs, is approximately equal to the change. All right, so this right here is our change. And as the section title kind of implies, this right here is the approximate change. So a lot of times we can use the derivative to guess or get an approximation or an estimate on the actual change going on in a function. So let's see what this is going to look like in an example problem. And again, this is going to be applications. There's no way to talk about them all. So I'm going to try to do one representative application with multiple parts, and hopefully you can apply it to other stuff. But if not, don't hesitate to ask me. Here we go. Example 5. You know what? This one is too long. This one is getting written out. I'm typing this one out. If you're writing this into your own notes, you will likely have to pause the video, unless you can write as fast as I can type, in which case that's pretty cool. So, example 5. Let P of X give the number of units produced when X units of labor are employed. So maybe the units, X units, maybe that's X hours, maybe that's X people working full time, maybe that's whatever. We'll just say units of labor, but you could maybe think about it as X total hours. So maybe if there's 8 people working 40 hours, then that would be 320 units, 320 hours. So obviously, if we work more, we should hopefully produce some more things. We'll see what P of X is later. And that's sort of where we're starting. All right, and get back in here. So that's what P of X is representing. If 5,000 units are employed, so 5,000 units of labor, we say P of 5,000 equals 300, and P prime, and P prime of 5,000 equals 2. And then we're going to ask a couple things about the situation. All right. I said if you can write as fast as I can type, then that's great. But I typed that pretty slow. And yes, I know this is not matching up with the lines, but voila. All right, let's see what we've got here. Part A. Interpret P of 5,000 equals 300. So we have to look at what is our input, what is our output, and what's going on, okay? So P of X, right? That's the number of units produced. So P of 5,000 equaling 300. This right here, this is our P of X. This is a number of units produced. Let's replace this, by the way. Instead of saying units, let's say like items. Because we're saying units down here too, and it gets a little confusing. This is how many items produced. Whereas this right here, this is our X. This is how many units of labor. So 5,000 units of labor are giving 300 items manufactured. So I don't know what we're building, but it's very time intensive. Okay, so this says with 5,000 units of labor employed, we produce 300 units. 300 items. I said I'm saying items, not units. And that's the answer to part A. Okay. Let's do part B real quick. Oh, wait, we're not done. Oh, yeah, we are. Interpret. Interpret. What does P prime of 5,000 equaling 2 mean? So remember that earlier we talked about the derivative. For a lot of applications, derivative has to do with marginal. Like marginal cost is C prime. Marginal profit is P prime. Marginal revenue is R prime. So you can sort of think about this as something like that, but it doesn't really translate. This P is not profit. So this is the rate of change. Okay, this is approximate rate of change. Look at the previous definition, right? The derivative times how many extra times the step size times the increase is the approximate change. So one way of thinking about this is the slope. This is the rate of change of how many items we're creating with an increase in our input. So this is kind of like the slope. We will go up 2 and over 1. We'll produce 2 more items with one more unit of time. Okay, so right, if we think about derivative as a slope, this is like 2 over 1, rise over run. This right here on the bottom, and why is keep getting some weird sensitivity. Right, this is an increase in our input, and our input is X. So this is the units of time. If we add one more unit of time, we're actually going to produce 2 more items. So this is a derivative. It's a rate of change, all right? And it says that if we produce 2 more items, that's going to take 1 more unit of time, approximately. All right? And this is maybe one of the trickier things of this section. All right? So again, think of it as a slope. And the rise, that's the output. And the run, that's the input. Rise over run, derivative, slope, change. These are all the same or very related words at the very least. We're going to say that so we have 500 units of time being invested for 300 items. But if we have 1 more unit of time, we get 2 extra items, which seems like a pretty good deal right now. And that's going to be our answer. So if we invest or employ 1 more unit of time or labor, we can produce 2 more items, which again is a way better deal than spending. I mean, we're already spending 5,000 units of labor for only 300 items. So we should probably increase, probably hire some more work or get people working more. Hopefully we pay them. Never mind. Part C. Estimate. Yeah, we're typing this one out too. Part C is going to be estimate the number of additional items produced when we increase X from 5,000 to 5,003. So this is where we're really going to use that formula. Okay. So if we increase our input, if we increase the units of time, the units of labor from 5,000 to 5,003, approximately how many additional items are we going to get? So let's go back to this formula that we mentioned at the beginning. The additional number of items that we're going to get is approximately going to be the derivative times the difference in input, right? So over here, this h, that's the additional input. So in this case, our h is 3. We're producing 3 more items. So we can get that change approximately by multiplying 3 times our derivative there. Using that formula, we're going to get that our change, we're going to say approximately f prime of 5,000, not f, times h, which is 3. Because this is the slope, right? The derivative is a slope. We want to know approximately how it is in 3 units from now. It'll be that slope times 3. We said p, right? P is our variable here, or our function. Yeah, so it'll be p prime of 5,000 times 3. And luckily for us, we know what p prime of 5,000 is. That was given to us. P prime of 5,000 is about 2. All right, so it's going to be 2 times 3. We're going to get approximately 6 more items. And it has to do with slope. We did some problems in the very early portions of this class where we said if the slope is 2 and we move over 3 units, how does the function change? That's exactly what's happening here. Okay, we know the slope. Here's the change in production. We just multiply those together to get the approximate change. All right, you'll see these on other ones, other problems as well. So part D is going to be, how about if we decrease from 5,000 units of time to 4,999.5. So now we're going backwards, right? So before, right, we were going from 5,000 to 5,003. That was an increase of 3, so h was 3. Well, now we're decreasing from 5,000 to this, so our h value, and again, it's still going to be the derivative at 5,000 times h. The derivative at 5,000 is still 2, like we said before, but now h is the difference, and it's decreasing now. It's going to be half. It's going to be 0.5, and negative because it's decreasing. So if we reduce the hours by 0.5 from 5,000 units or hours to 4,999.5, this is the approximate change. This is the approximate change formula. So we're going to be using this a lot in these problems. So maybe box this with a nice yellow box. We'll introduce a little bit more color. And then we just multiply these together. And it should be -1. We get about 1 fewer item. If we lower the hours or units of time, units of labor, however you want to phrase it for this problem. So these ones especially are probably going to be pretty tricky for a lot of people. Don't hesitate to reach out. Good luck. And you only have a quiz this week. No more exam for another couple weeks anyway. Bye-bye.